Hello everybody, this is your science video for today, 5/20, Wednesday. So when we left off on Monday, we were talking about compression waves and sound and how compression waves measure sound, and we had this visual over here, right? So sound travels through air, it produces energy. It can be measured in waves, just like waves in the sea. Okay, so now we're gonna get a little bit more into sound and why different sounds sound different, and why something might sound like ear piercing and something sounds more low. Okay, so all the details of different sounds. Okay, so I'm on page 650. It sounds like. Okay. All right. I'm going to start reading below where it says it sounds like, the subheading. It says our world is full of sounds, many of them pleasant, others harsh or annoying. And we all know that. People measure characteristics of sound in order to understand, describe, and control how sound affects our ears. Pitch and volume are two useful ways to measure sound. The highness or lowness of a sound is its pitch. A flute, for example, produces high-pitched sounds. A tuba produces low-pitched sounds. This is I'm gonna look silly doing this, but I'm gonna do a high-pitched sound and a low-pitched sound. A low-pitched sound would be like this, and a high-pitched sound would be like this. Okay, that ear-piercing kind of sound. Okay, so high pitch, low pitch. Just think of low pitch as like bassy. Okay, and then the next way that they're going to talk about to measure it is frequency. It's highlighted in yellow. Well, yellow on my page. Your page is probably just darker. Frequency is the number of vibrations that occur during a unit of time. A sound with a high pitch has high frequency. Low pitch sounds have lower frequencies. So think of this like your heartbeat. How many beats per minute it's doing, okay? So a high pitch sound is beating really fast. It's a lot of frequencies per minute. A low pitch sound, they have lower frequencies, okay? Slower. Okay, the loudness of a sound is its volume. So this is completely different than pitch, okay? Just because something is low pitched or high pitched has nothing to do with how loud it is. Okay, so the loudness of a sound is its volume. Volume is measured in units called decibels. It's abbreviated as dB. The softest sounds that humans can hear are 0 decibels. The humming of a refrigerator is about 40 decibels. Heavy city traffic is about 85 decibels. And any noise at this level can cause hearing loss if a person listens to it for a long period of time. It's wise to wear earplugs if your ears will be exposed to 15 minutes or more of noise at 100 decibels. No more than 1 minute of noise at 110 decibels is safe without ear protection. Okay, so you just have to remember that you can get ear damage from listening to really high pitched high volume sounds. Okay, okay, so going up to the top of the page, we see the frequency of a bird, and then the frequency of a dog, which is lower pitched. Okay, so it says a bird song has a high pitched and a high frequency. Its sound waves may have many vibrations per second. This dog's bark has fewer vibrations per second. It has a low pitched and a low frequency. Okay, so now I want you to put pages, if you can, 650, just flip, look at 650 and 51 at the same time. Actually, you don't need to. It's just the part of this picture is there. Sorry about that. So the lightning is here. But you could just look at page 651 now. Sorry for the confusion. Okay, this picture. So let's read. It says 120 decibels for lightning. That's how loud it is. And it says, if you are close to a lightning strike, the resulting thunder can be loud enough to cause pain in your ear and probably damage your ear. The next thing we're looking at is a guy, I don't know if you could make it out, but it's actually a guy's legs and feet and a drill, or a hammer, okay, drilling into the ground. And it says sounds that are 85 decibels or louder can cause damage to your ears. 80 decibels, train, that's about the volume of a train. And then if someone's whispering to each other, whispering to one another, it's 20 decibels. Okay, so for this chart, right up here, it says turn that down. Okay, so it says the number of sounds in the first column, 1 through 6, number the sounds, this is the directions. Number the sounds in the first column, which is here, all these blanks, in 1 through 6 in order from quietest to loudest. Put a star next to any sound that could damage your ears. Okay, so they want you to number it from quietest to loudest, which is basically the lowest number to the highest number. So I'm not going to do that with you guys because you guys know how to add. You know that 60 is less than 150, okay? But what I am going to do is go over with you which ones would cause damage to your ears. Now remember, on page 650, it said heavy city traffic is about 85 decibels, and any noise at this level can cause hearing loss or damage to your ears if it's listened to a long period of time. So anything 85 and above is going to get a star, okay? So 60 is below 85, 150 definitely you put a star next to that, okay? 20 for whispering voices, no. Ambulance siren, 120 decibels, you get a star, that gets a star, that's above 85. Power lawnmower, 90, that gets a star. And certainly a personal stereo system at its highest volume, 105 decibels, that gets a star, okay? And then the only thing you have to do on your own is put them in order from least to greatest, the least, quietest to the greatest at the bottom, the loudest, okay? All right, let's turn to page 652, looking at waves. Okay, a tiny kitten and an adult lion make very different sounds. What words would you use to describe exactly how they are different? Okay, so people don't only use words to describe sounds, they use diagrams. Waves consist of curving lines that go up and down as they move away from the sound source. Each high point of a wave is called a crest. Okay, so we have the visual here. That's the high point of the wave. That's the crest. Okay, while each low point is called a trough. Okay, that's the low points. Okay. The distance from one crest to the next crest is the wavelength. Wavelength can be found by measuring troughs too. So the wavelength is from this point to this point, or you can measure down here, the trough, this point to this point. So you could either measure two crests or measure two troughs. It's going to be the same distance, okay? And that's called wavelength, okay? Going over to page 653, I'm going to read the main paragraph, okay? It starts with amplitude, describes the amount of energy in the wave, okay? So that word amplitude, not amplitude, that's why I keep messing it up. It's amplitude. Describes the amount of energy in a wave, okay? That's how the amount of energy is measured. A jet engine produces a sound wave with an extremely large amplitude. On the other hand, a pin hitting the floor produces a sound wave with a very small amplitude. As you may have guessed, the volume of a sound and the amplitude of its waves are related. because large sounds have large amplitude, whereas soft sounds have small amplitude. So the softer the sound, the smaller the amplitude. The larger or louder the sound, the larger the amplitude. Okay. Amplitude is measured by finding the distance from a wave's highest or lowest point to its midline. Okay. So the midline is a horizontal line drawn straight across the middle of a wave. So this is the midline right here. This yellow, what's yellow on my page? Okay, that's the midline. Okay. So I'm gonna read right here, right below the diagram. It says the taller the wave is from its resting point, the larger the amplitude, and the more energy the wave carries. So that means the more, basically the higher it is, the higher the amplitude. Okay, the lower or more shallow it is, the less energy it's gonna carry. Okay, less amplitude. You see a picture of a pin. It says dropping a pin onto a hard surface produces a soft sound with low amplitude. So going back to page 652, shows you the first half of the jet. It says turning on a jet engine produces a very loud sound with high amplitude. So I think what they're doing is here, they're showing the amplitude of a jet. You could see it's very high, okay, very peaky. This would probably be the amplitude of the pin dropping, okay, much more calm and less steep, okay. Okay, so the question is size matters, okay. So we're in the box here, the question that we have to answer on 653. Size matters. Look back at the previous 2 pages. List the objects that produce sounds with high amplitude. How are a wave's amplitude and volume related? Okay, so it's a 2-part question. Okay, 1 second, let me just get my pen. Okay, so let's do the first part. Looking back at the previous 2 pages, we're going to list the objects that produce sounds with high amplitude. So that means high volume, okay? So let's see what they mention here. Okay. So I'm going to do anything with 85 above, okay? So they give the example of heavy city traffic, okay? So I'm going to write that down first. Okay. Okay, so heavy city traffic has high amplitude. Okay, you could pause the video if you need to copy it down. The airplane, we're going to write down, airplane has high amplitude. Okay, that's the other example they just gave on this page. And let's write one more. What did they say here? I think a lawnmower was one of them. Let's go with firecracker. It's 150 decibels, okay? That was on the other page, firecracker. Okay, I'm gonna stop there because I want to have enough room for us to finish the question, answer the second part of the question. So firecracker would be the other thing that has high amplitude, okay? And then the second part of the question is, how are a wave's amplitude and volume related, okay? So basically the higher the volume, the higher the altitude. That's how they're related. The higher the volume, comma, the higher the amplitude is. Okay. And then I'm still not going to have room, but it's okay to write outside of the box. The lower the volume, the lower the amplitude will be. Okay? So, to answer the second part of the question, how are waves amplitude and volume related? It's the higher the volume, or I'm sorry, the higher the the higher the volume, the higher the amplitude, and then the lower the volume, lower the amplitude. Okay, so they're interrelated. Okay. All right, and that's it for today's science video. We're gonna get into more detail on Friday, even more detail on how sound travels and some other things, facts about sound. So thanks for watching. Hope you enjoyed.